Ladies and gentlemen, today in this episode I'm going to show you how to find the area under a curve or the area between a curve and the x-axis using the integral function built into Geogebra, and I'm also going to show you how to use sliders to assist you in function transformations. To get started, I have a function plotted. It's a rational function with an asymptote at positive and negative 3. We're just looking at stuff in the positive region though, so we are only able to see that asymptote at 3. And I'll be dealing with this portion of the curve specifically. And I would just like to find the area under any point of this curve. So just like the max-min functions or the root functions, I can specify what function I want to find the area under and the range or the domain on which I want to find the area. So it's not called an area function, it is called an integral function. So I'm going to say integral, that's spelled like that, and you'll see a whole bunch of things pop up. And you'll notice that one of them has a function, a start value, and an end value. So the function's name, the start value, and the end value, and that's the one we're going to use. I named my function f, and I'd like to go, you can choose any numbers that you want, 3.5 to 8. Well, let's go a little bit further. Let's go 8.9. And that'll get me almost, a lot of the curve between those two roots there. If I hit enter there, you'll see that it shades it in for me and it gives me the value right there. It also gives me the value in the algebra bar if you've chosen to display it. Now, if you want to choose different limits, you can go ahead and choose different limits. And the other cool thing about this is, or maybe a warning, or maybe it's exactly what you want, but it's going to count any area under the x-axis as being negative. So that can work to your advantage or disadvantage depending on if you remember that one simple fact. So if I extend, for instance, the limits to beyond this 0, then the curve goes under the thing, so it counts as negative area. So if I extend this to, say, maybe 11.5, we should see the area here go down. I can modify the integral function that I just entered by either clicking and holding or right-clicking and going to Object Properties, and you'll see that the definition comes up. So if I want to extend that to, say, what did we say, 12 or so, I should get a number that's less than the current readout of 12.9 because it's going to count some of that area as being negative. Go ahead and hit Enter and close this out, and you'll see that now we have a shaded area above and a shaded area below, and where it used to be 12, now it's reading a 9.2. So it's a really simple function. All you have to do is change the limits and you can find the area under any curve. If you do want the positive version of both, I would suggest running an integral from here to here and then also from here to there and adding them together as if they were both positive areas. That's all you really need to know from this integral function. Next, I'm going to take a look at how to do function transformations using sliders. Okay, the next thing I want to show you in this video is how to use GeoGebra to help you do function transformations. So what we're going to do here is I'm going to play around with this function, which is an x to the 6th function. So basically a parabola that's been a little sharpened. And what we're going to do is we're going to insert parameters into the x to the 6th equation, a, b, c, and d, so that I can perform a vertical shift, vertical stretch, horizontal shift, and horizontal stretch at various points. So the way we do that is we go into the input bar and we define a new function. I'm going to call it k of x, and we're going to set it equal to capital A, and it's going to be really important that you put a multiplication symbol right there. And in order to convert that formula that you see on the screen to something that GeoGebra understands, you're going to have to nest a set of parentheses. So we need 1 for the x to the 6th function, and we need 1 for the numerator of the fraction that we're going to write. We go x minus capital B, and I'm being specific about capitals. I'm going to use the division key, and then capital C again, parenthesis, and then don't forget the caret 6, and then plus capital D. Hit enter, and it's going to ask you if you want to create sliders for each of those variables. Yes, you do. And you'll see that they all pop up right there. You get your brand new function right here. I'm going to make that a little thicker so you can see it. And that's about it. Now you have the ability to change the sliders, change the values. You can see D is the vertical shift. C is the horizontal stretch and shrink. So if we put that back to 1, we basically get the parent. B is a horizontal shift. And then A is a vertical, stretch, or flip. Same with the H. So if you wanted to, say, mold a function into the shape of something, this will allow you to basically locate it and place it anywhere you like. And that's all well and good as long as you know what you're gonna, or what you want your function to look like in the end. Now let me show you one other little trick here, is that you can insert an image to kind of help guide you. So if you insert an image and then click to where you want the image to be, about the lower left hand corner of it, it's going to ask you for a file, and if you happen to have a picture waiting for you, say this force curve right here, it's going to insert that. Now sometimes it stretches it and shrinks it, so if you object properties, do absolute position on screen, and then with your selector tool you can pick up and move this anywhere you like. You can turn off the points that describe it, and here's the cool trick, is if you go to object properties, you can create it as a background image, so that way you can basically take your function, and I know it's obviously not going to work right here, but you can make the scale fit just by moving this over here. So you can kind of match the scale, you can match the scale here with a little bit of work, but you can line everything up, including the function. And obviously, like I said, obviously this is not going to work because there's no way I'm going to get an x to the 6 to look like this. But you can see how just by manipulating the picture into the background that you can work with the foreground and get your function to match whatever you might want it to match, in this case a force curve. With that, I'm going to leave the rest to you, and I'll see you next time.